Hello everyone. In today's session, we will be learning about ARM ISA. What do you mean by ISA here? ISA stands for Instruction Set Architecture.
The ARM instruction set architecture is a family of computer processor architectures developed by ARM Holdings. It's one of the most widely used ISAs in the world today, especially in mobile devices, embedded systems, and increasingly in servers and desktops. Okay, so when you call something as ARM, it is nothing but Advanced RISC Machine, while ARM ISA defines how ARM processors operate. That is, it specifies the available instructions, the registers, the memory addressing modes, the execution model. Okay, it has evolved over several versions, maybe ARM version 1 to 3, okay, which were early versions. Then we had ARM v4, which introduced the ARM 7 core. Then we have ARM version 5, which added thumb instruction set. ARM version 6, which introduced SIMD, which is single instruction multiple data. Then we have ARM v7, which is split into three profiles, which includes application, real time, microcontroller, ARM. Then we have ARM v8, which is a major update introduced 64-bit support, and finally ARM v9, which is the latest version focusing on AI, security, confidential compute, and 64-bit only. Okay. When it comes to addressing modes, ARM supports various addressing modes for memory access, such as immediate offset, register offset, pre-indexed with write back, post-indexed. Mode of operation, ARM supports user mode, FIQ, which is fast interrupt mode. Then you have regular interrupt mode, which is IRQ, supervisor mode, which is OS kernel mode, abort mode, which is memory fault case, and then we have undefined, which is undefined instruction, and system mode, which is privileged user mode. Conditional execution. One unique feature of ARM is conditional execution. Nearly every instruction can be conditionally executed based on flags. ARM has support for interrupts, software interrupts, resets, aborts, undefined instructions also.
If you are considering the execution states, then we can find two different modes in which the CPU can operate. One is ARM architecture, 32-bit execution state. One more is ARM architecture, 64-bit execution state. Okay.
If you consider the ARM instruction sets available, at first it includes general purpose instruction sets such as ARM, Thumb or Thumb2, and A64.
A64 stands for ARM 64-bit instruction set encoding.
Then we have vector and SIMD instruction sets. Then we have floating point instruction sets, etc. Okay, so these are the different instruction sets available.
Our focus will be on 32-bit ARM instruction set in the ARM architecture 32-bit execution state. Okay. SA defines the set of instructions the processors can execute. Like, for example, adding two numbers, loading data from memory, or jumping to another part of the program. And since ARM is a RISC processor, that means reduced instruction set computer, it focuses on simple, fast instructions, all typically the same size, that is 32 bits. Okay. Processors, they use registers to store and work with data. Okay, these registers are super fast, tiny storage units inside the CPU. The important things you should know about registers are R0 to R12 are general purpose registers, R13 is a stack pointer, R14 is a link register and R15 is a program counter. So R13, R14, R15 are special purpose registers, while R0 to R12 are general purpose registers. Next, we will discuss about ARM registers and load store architecture. Unlike some CPUs, ARM uses a load store architecture. What exactly does it mean? It only interacts with memory using special instructions. All other works happen in registers. That is, you cannot modify or manipulate the data which is stored in the memory. If you want to make any changes in that, you will copy that content to the register, make the necessary modification there, and then copy it back into the memory. And this copying from the memory to the register and from the register to the memory happens using load and store instructions. Okay. Next, we have the different instruction types available here. Okay. So overall, we have data processing instructions like add, move, etc., which performs any mathematical operations, logical operations, comparison, etc. Then we have load store instructions where we move data between memory and registers like LDR, STR. We have branch instructions which changes program flow like B, BL, BEQ, etc. Then we have software interrupt, okay, which requests OS, that is operating system, or system service, okay, like ESWI, ESVC, etc. Then we have program status register which access or change CPU status flags using MRS or MSR, okay, instructions. All these instructions work together to run your code efficiently on ARM processors.